Oh, hey everyone. It looks like XSplit has done something quite interesting to my camera, so let's just fix that. That's better. There we go. Cool. Welcome to another Friday Sessions. A little bit of a small group this week, but hopefully that means that we can answer these questions when we get to the end. So that isn't such a bad thing. Let me share my screen. Cool. Here we go. I need to do one of those as well. Today we're going to be looking at audio reactive notch patches. I did, if I can grab it, I did create one of these this morning, partly as a test and also to do a bit of a preview for what we're going to learn. So let's just open that up and we'll have a quick look. And then we'll start with this blank project and we'll go through it. Cool. So here's the node graph and the project that I generated this morning. Oh, and we've got a bit of audio on that. Let's just turn those down. Okay, so we're going to generate an audio reactive landscape that looks a bit like this. And yeah, we just dig straight into it, I guess. It should be fairly simple. So let's get rid of that one. As we go through, I think it's probably, so to start with the audio side of things, I've been using Epidemic sound to grab audio which is sort of free to use on YouTube. There is a subscription for it, but being able to use the content YouTube without getting a copyright strike is pretty important. So the other thing that I think is really good about Epidemic sound is if I grab, so this is the audio that I used for the demo this morning. Not only do you get the actual file itself, but you can also download the stems, which might become a little bit more useful to us when we start doing our interactive audio piece. The other thing that I wanted to show is Kevin Zhu, who recently just won the second Notchmeister, incredibly talented notch artist. A lot of the techniques that I'm going to use today he lays out in a really nice audio reactivity tutorial, which I'll link when this finally goes up on YouTube. So obviously glad you're here to watch mine, but if you want to look at some other ways of doing audio reactivity, I think Kev's tutorial is really comprehensive. So yeah, check that out. That's really useful. Yeah, and I think that's it really. So I'm just going to grab all these audio bits and pull them into my resources. Let's see. I'm just going to work with the sort of the full audio piece at the moment, and then if we feel like grabbing the stems later, we can sort of swap that out. I know that if I play that straight out, it's going to be super loud. So if we just play that, hopefully that's coming out over the stream and not deafening anybody. You can still hear my audio. The kind of crux of making this work is the FFT texture. So we're going to pipe our sound into the sound input of an FFT texture, and then in order to see what that looks like, if I grab like a shape 3D, and we're just going to make that a plane. Probably don't need that to be wireframe. Make that a little bit bigger, so there we go. And then I'm going to subdivide this. At the moment we've got 20 subdivisions in each direction. We'll need to give us a bit more of that so that we can see the displacement, and that's the next thing I'm going to grab the displacement deformer or displacement map. So we're going to use what the FFT texture does is if I solo that to my viewport, as the audio comes in, it shows you the peaks as like white dots, and you get to see a certain amount of history in terms of what's just been played in the audio, which makes this really nice for generating displacement for something like this. So I've just turned the scale up there in order to make these a little bit more obvious. We'll probably come back to this to tweak some of these settings as we go through this. I'm just going to increase the resolution of this. What you can see, like, so at the moment, this is showing you all the different frequencies that we're listening to in our sound file that we're using to generate this map, and basically the baseline's playing. So the lowest frequency is at the top of our file, and the highest frequency that we're listening to, which is sort of around 8K, is going to be at the bottom of the file. So we can pipe that into our displacements and then attach that to our shape. And if I play that back now, we can see it's very subtle, but we are displacing the plane using our audio. That's a little bit subtle for the effect that we want, so we can turn the displacement amount up. As we go, throughout this entire tutorial, a lot of this is going to be tweaking some of the numbers that we have on these. So we're probably going to keep coming back to these nodes quite a lot. So if I shift and double click on my FFT texture, I can see what that looks like. And in order for it to drive the displacement node, that needs to be a black and white image. If I grab a material, if I can spell material, we could attach this FFT texture and then show what's going on our plane. So where we're getting the light parts in the map, we're getting the highest sort of peaks in our displacement. One of the things that we're going to want to do is colorize this. So if we colorize the FFT, our displacement wouldn't work. So what we need here is a video null. Again, you can shift and double click on that, and that will show you what's inside the video null. So I'm going to replace the input to the material with that, and then grab a recolor node. And this will allow us to use a color ramp, and we can recolor. So by default, this is just two colors which are both white, so just give us a little bit more room to maneuver. I think in the version that I did this morning, I did sort of like a traffic light system, so it was like a green, like a yellow, an orange and a red. You can see straight away where the whitest parts of that map are. We're now recoloring those to red, and all the way through the grayscale until we get back down to green. I think this is quite useful, although these are not necessarily the colours that I'm going to want to use for the final piece. I think this is kind of a very contrasting setup that we can use to kind of get this all set up, and then we can get into making this look pretty further down the line. This isn't looking too bad. In the version that I did this morning, I actually had to remap the texture because my my peaks and my colours weren't lining up. So I'm just kind of trying to work out if that's the case right now. It seems pretty good. Perhaps isn't as much displacement going on there as I would like. It's not too bad. So what I did is I generated a couple of these setups. So in order to move these around, I'm going to stick this, make this a child of a null. And although I could move this around, I think it's just a little bit easier to kind of visualize where your controls are by parenting everything to a null. So I can kind of, in order for my brain to work, I always like the sort of depth to be in the Z direction and the left to right to be in the X. There's kind of no rules to that, but that just that's going to keep things working the way that I'm expecting as we continue to build this. So we can basically copy all this. If I press Control R while I have the null selected, that's going to parent it back to the root node. This isn't working on our copy because we don't have our displacement information, and if we, although we can't see it because they're overlapping, our material needs its texture as well. If that all, there we go. So again, we can grab this null and hopefully giving that a -5 should make it do what we want it to do. These are running left to right, and as I say, I prefer my depth to work front to back in the Z direction, so we're going to need to turn these around. I think this is where my read mapping node came in, so if I just do 90 degrees, that's the wrong 90 degrees, so we do -90 there. So now our movement is kind of going away from us. Do the same to this one. So if I grab that mapping node, we'll pipe that into our material. You can see this checkerboard is like a visual representation of how your material is being mapped onto your geometry. So we can see it's sort of heading off in the Z direction. If I go 90 and then move it across, because I've scaled my plane up, we're now seeing that tiling, so we need to make this the same size. If I do 5, 5, trying to work out if that's correctly mapping the height now. I don't think that is, so that didn't do it. So I've made my pitch -90, which is basically sort of flipped that over, and now we're seeing that our colours and our peaks are matching the displacement properly. I'm looking for a line of symmetry down the middle, and in flipping that over, we've now got that. I just need to, again, I'm looking now on this side to see that our peaks and our colours are matching up. I'm not sure that they are. seemed like it right at the edge there. So we'll grab another mapping node. We'll just use that to fix our texture orientation. -5. So that's now mapping. It's correctly mapping the peaks and the colours together. However, they're both. We don't have symmetry down the centre line here. So if we just grab this and we want to flip that over. Inside we can't see the texture here because inside the material it's set to show front faces, so if we make that double-sided. We did it. It's good, it's upside down now. Perhaps that wasn't quite the right way to do it. So I can see that the geometry now has the symmetry that I wanted to, but I'm just I need to update the mapping to. Oh, that might be why. To make sure that that's giving me the symmetry that I want. So that's looking a lot better. I wish there was a bit more of a logical way to kind of work all that out, but I'm sure if you analyze the numbers, there is. I often tend to end up just sort of playing around until I get the look that I'm looking for. So let's move on from here. In order to kind of make this setup that we've generated here be treated like essentially a single object, we're going to make those a child of another null. So I'm going to lose those connections to the root node, and then parent them to the null, which now, if I was to move this around, it means everything's now going to move together. They're still using these mapping nodes to apply the texture, so that's why our texture slipped a little bit there. I'm going to put that null in a cloner. So again, dropping the connection to the root. And then I think the way that I did it this morning was using Iterative Cloning. So I'm going to create 10 clones, and we're going to move in the Z-axis, so in depth, by increasing that number, hopefully to around the size of our objects. We should get them to not overlap. Below, looks like we still. Oh, there we go. Perfect. So the other thing that I did is I kind of overlaid like a wireframe version of this on top. So I probably could have done this before I generated the cloner, but if I grab these setups, Control D on the keyboard duplicates them, and then I'm just going to grab another null. We'll just turn the cloner off for now. In fact, I'm just going to set this back to the root node as its parent, so that I just have one copy of that. So again, with these setups, we need our displacement information and we're probably going to use different color information, but just to keep it kind of let's just hold off on that for the moment. So what we're looking for here, if I grab these two materials, I'm going to come down and set this to be a wireframe. So this gives this like a different sort of textural pattern to it, and then I moved that slightly up in the y-axis. The other thing that I did, so if I grab another video null, so what I want to do is make a copy of my colorized FFT texture, so pipe that in there. But we want contrasting colors that are going to work with whatever we've got in the sort of solid texture. So I'm just going to invert there, and then this color is going to be applied to those materials. Okay. It looks pretty hideous at the moment, but we can probably find a color scheme that's going to work better for this. Cool. So back to cloning. Unparent these from the root node, and then throw it back in the cloner. All the time I'm sort of just keeping an eye on that the peaks and troughs are marrying up to my colour information. So I'm going to grab a second version of that cloner for our mesh version, and then for whatever reason if I do my position in my cloner, we're going to end up with like a stepped effect like that. So let's go back and do that in the null. So the null is holding just making that slightly higher than our sort of mesh underneath. Now I don't want to see the mesh everywhere. At the moment it's kind of distracting that that it's kind of overlaying on top of everything else. So what I'm going to do is use the FFT texture as an alpha map. So again, grab another video null, just see that there, and then I can never remember which one of these it is. There we go, alpha. A lot of things like that. And then we have to go into our material and let's pop up where to. It's still, so the reason that this map hasn't had any effect on the geometry there is that our alpha mode is still set to opaque. So if I do alpha to blended, reduce our alpha, so now we're seeing more of the mesh where we have strong white marks, and we're seeing less of the mesh where. So if I turn my grid off, you can see this a little bit better. If I reduce the alpha amount here, we should be seeing it a lot less in the flat and a lot more on the peaks, which I quite like. I'm really hating the green there, so let's go back into our colour ramp, and we might need some sort of more contrasting or more complementary colours perhaps. This is kind of for you to play with and make it look a little bit more interesting. That's kind of the technical part of this, and then I'm going to show you how I sort of turned that into a bit more of a scene. So if I sort of grab a camera, eventually we're going to put this into disguise with and use it on a smart stage. So I'm going to skip using a standard camera and grab an exposable camera. Just parent that to the root, and then I can say set to current view, so that just maps it to my current editor camera. I might want to just redo my view there, and we can sort of catch that up. Cool. Okay. So pop back to editor camera. I'm just going to grab a null. So these two cloners here essentially hold our whole setup to do this sort of main floor. I'm going to parent those to a null. Let's grab those, and you can use multiple nulls to take copies of things like this. So if I get a second null, I can then lift all that up, and then I think I just turned it over. Oh, not that guy. There we go. So turn that over to create kind of, if I go back to my oh, it might get mad about this because it's not JLC, so I'll need the one that I used this morning in the Facebook group. Here we go. So yeah, this is our sort of top layer here. Move that out of the way. So it's starting to look like something. I'd like it to look a little bit nicer colour-wise, and I'd also like to see some more peaks and troughs. One of the reasons I used a video null here to take a copy, I could have just basically piped that from the FFT the way that it's currently set up right now. If I use a glow, I can just soften out the alpha texture by doing that. So if I I'm not sure that using the invert necessarily gives us the colour palette that we want, so we can drop that and then just it's a little bit more complementary. So I've just made a copy of those on this second video null, and then we could maybe do something that we know is going to be a bit more complementary. Still too much green for my eyes. Slightly more neutral. That's kind of fun. It's sort of a bit icy. There we go. So as I was saying, it'd be nice to see some more definite peaks and troughs here. If we use this as our reference, I kind of made that made them a little bit, the amplitude of those a little bit higher. So we could sort of keep increasing the scale here, but we're just going to end up basically with a shelf. So that's perhaps not the right way to do it. I think this spikiness is kind of useful. Now I'm just looking at my displacement nodes. Yeah, it's a bit nicer, so I'm just going to grab all those. I can't see the parameter I'm looking for. There we go, right at the bottom. Make more 1.5. I think this might be something that we want to sort of keep coming back to and tweaking. So whenever I have something like a parameter that I think is going to be important to the scene, I grab an envelope modifier. So what I'm going to do now is attach this to this displacement amount for each of the displacement nodes. If I set this to multiply, basically when you set a modifier like that to multiply, the number that you put in here basically becomes like a max value. So now if I set this to 1, these will be 1.5, and then this kind of normalizes it. So from 0 to 1 becomes a value between 0 and 1.5. We could go in and we could say replace if we wanted to override that, but I think this is sort of quite a nice way of doing it. To remind myself, when I come back to this, I'm going to say that this is amount. It's always good to label things. So the black is a little bit jarring. What I did on mine is I went to, let's find it. I think it's called HDRI Heaven. HDRI Haven. I just bring that in and downloaded. These guys do some fantastic HDRIs completely for free. So these were great. I think I grabbed like it's a sky that I wanted. I wanted like a nighttime one, so might have even been this. For the sake of not making this take too long, I'm just going to grab that. Cool, so brought the HDRI in. I'm just going to grab Skybox, Control R to parent that to the root node, and then bring the HDR in. Which is good. It's kind of unrealistic to have that, so I'm just going to rotate the Skybox around to find a little bit of, yeah, a little bit of night. And the way that I sort of made that a little bit less jarring is I grabbed a depth of field node. Just this guy. Is that right? quite doing what I was expecting, but just see, I didn't do this on an exposable camera earlier, so let's just swap those out. Because I'm not. So I need to select my camera. Huh. Let's just lose that. There we go. Maybe they don't work so well together. I like to use a null as a target for my camera, so put that into the camera target node, and then if we go back to our editor camera, just so 0 sets me back to my scene camera, and then in this null I can sort of move around the sort of focus of my camera with the depth of field. Sort of see. Sort of strange that that wasn't working the way that I expected it to on the exposable. Excuse me while I just have a quick play with this. Oh, it does seem to. Not sure what went on there. Okay, that's kind of fun. Well, we're going to use an exposable camera shortly, so we'll keep that there. Let's go back to our reference. In this one, our geometry is coming towards us rather than away from us, which is fine. I'm quite happy to just keep this the way that it's working there. That does make me mad. What we do have on this other one though is a particle system which is responding to the baseline. So I'm going to quickly set that up now. So grab a particle root. I'm going to press 5 on my keyboard to grab my editor camera, because we want to look at where we're sort of setting this up. So my exposable camera, if we look like that, is right at the start of the scene. So if we sort of zoom out, setting all my particles up right at the end here isn't necessarily going to help us get the look that we're looking for. So I'm just going to grab a primitive emitter. So this is just going to give me a big pile of particles. Let's look at where that's going to be placed. So right now that's kind of behind the camera, which is why it's important to look at where this is going to interact in your scene. Let's set this to a plane. Can scale that up. So, possibly even bigger than that. Okay. Be right in the foreground of our camera. We won't be able to see our particles until we render them, so let's just make this a point renderer. If I now press Ctrl-R on the keyboard, that's going to parent me to the particle root. So Notch is clever enough to understand that there's no reason why you would pair a point renderer direct to your scene root. So it'll pressing Ctrl-R will parent to the nearest sort of most logical root node. So that's kind of useful. So if I press play, we can see that, or perhaps go back to our scene camera, we can see that there's some, see these white dots here are particles being generated and rendered, but they're not really doing anything that interesting yet. If I go to, let's like grab a turbulence. So just as standard in the scene, I want them to have a bit of kind of organic movement. Go back to here, maybe a bit more than that. If we stop that, you can see each one of these particles is being rendered as a flat square, which is fine, but it's not really the look that we're going for. So if I grab gradient, I'm going to press Control F1, and that's going to show me my gradient in my viewport, and then we're going to change this to be a radial gradient, and then so this is basically setting what our particle could look like. So we could make that a hard circle, but something like that might be good. There we go. So now we stick that into our not our emitter, but our renderer. Come on, Rich. There we go. So they look a bit dark there, so let's just the other thing that you need to do when you do this is just tell it to process only once, because it's going to be better performance when you do that. Right, so let's have a look. Our renderer, we want to increase the size of our particles, probably quite a bit, maybe not that much, and I've changed that. They're all, I just kind of want this to be not so hard with a big glow on it. Just looks kind of weird when you do it like that, doesn't it? Let's reduce our particle alpha, which will sort of help with that, and then we're going to want to increase our size randomness, because at the moment they're all the same size, which is kind of a little bit weird. I think what this scene is missing is, in general, is a bit of glow. That's way too much glow. The camera is we were seeing the end of the plane there, so I just moved that forwards a little bit. Let's go back and work on our particles. It's looking a little bit better. Kind of halo around them I'm not massively fond of. And if we press 5, I think we could probably make our emitter quite a bit longer. So let's make that, and then you just sort of size that up a bit. I'd like to see particles sort of head further into the distance. So 0 on the keyboard to go back to our scene camera. So let's add some. Before we get too far, I'm not quite happy with the particle system yet, but let's get some audio reactivity into that before we do any more. So it was the baseline that, oh, there we go. So as you remember at the start of this, we turned the volume right down on the volume control, just so it doesn't overpower the stream. So let's just match those, and that should, when we play back, it should just about blend into the background. So I'm going to grab that. Probably if you've done any audio reactivity before, you've had to play with the sound modifier. So I'm just going to use one of those to control this, and then grab a velocity effector. So in terms of, there's no rules about how you lay these things out, but I tend to like to keep my effectors separate to my emitters and my renderers. So if we look at our velocity effector, I'm going to go 5 to look at our scene camera and see that that's not really overlapping. If we think our emitter is this big square here, you can just see the white outline of it. Having a velocity effector over here isn't going to be that useful to us. If we zoom on into that, we should be able to see an arrow at the center of it. So I wanted to shoot the particles up in the air on the baseline. So if we do a -90 on that, I'm just going to set this further into the scene. I can press, if I press Alt on the keyboard when I'm moving these values, I can go above and below the sort of limits that are set on these particular boxes. So back to the scene camera by pressing 0. So that effector is working on the scene, it's just doing it all the time. So we can see it's pushing all our particles in that Y direction. So let's stop that. I'm going to say my baseline, I want to control the velocity amount, so we'll just arrow those in together. Again, we use the whole waveform because actually by using the stem we know we've only got the bass coming into this sound modifier. I'm going to set this to be multiply again. That means that the value that we set here is going to be the top limit. So if we play that again, right at the start of the track, we don't have any bass lines, so they're just going to be floating around. Okay. Not quite as dramatic as I would like that to be, so we're going to increase our sort of max limit on that and then just have another go. Doubling it should hopefully give me the look that I'm looking for. That's kind of fun. Still could be a little bit more obvious, so we might just turn that to 3. There we go. It's obvious now that the baseline is sort of affecting the particles. So there we go. Now we could keep playing with this as long as we like, really. When it comes to the kind of art side of things, there's no rights and wrongs. It's just about creating something that you either personally like or meets the brief of your client. So you know, those things might not always be the same either, but you can certainly keep going and tweaking this. We've created a nice little bit of splodge there. I'm just gonna, you'll see, in a very dangerous way, I've not actually saved anything since I started this, so I think it'd be pretty good to make this a save file. So this is our audio reactive, but this is the live version. So we just save that out. So now, as I promised at the start, we're going to look at bringing this into Disguise and applying this to a smart stage. So let's go live. Smart stage. I made a mistake last week by building this in a beta version of D3, so when I shared the project files, people weren't able to use that. So yeah, this week we're using hopefully the latest gold. Here's the new project that we've generated. If anyone doesn't know, I'm sort of assuming that everyone's kind of across this whole smart stage thing. Smart stage, I think, although I could be wrong, is a term that's kind of been coined by Disguise, where a LED set is blended with AR in order to the main benefit of it is your talent or your performers get to see visually what's going on around them by the feedback that they get by seeing your graphics on the LED. But then you can use some of the new AR features to extend those graphics beyond the end of the smart stage. So I think it'll become fairly apparent as we're building this what's going on there. You might know more about smart stages than I do as well. I just think for anybody who is coming into this not knowing about smart stages, it's worth a few sentences on that. So in order to be able to use our notch block in Disguise, we need to be able to control, we need to expose any of the parameters that we want to control in there. If I was doing this for a commercial project, I imagine I would probably expose things like the displacement amount. In fact, let's do that. And I'd definitely be exposing the colours, because I think those are the kinds of things that I'd want to tweak. Probably the glow intensity as well, because I think that's something that we want to, possibly even the depth of field. You can expose as much as you like, but the limit is it becomes unwieldy when you get it into Disguise. So less is more when it comes to doing to expose some parameters, but you do need a few bits to actually be able to control it. So the main one for setting up anything AR in Disguise is making sure that your exposable camera has its exposable camera values exposed. So I'm going to compile this block from my media server, and then find the project file that we just created there. I'm going to open up my objects, and in the notch file folder, live demo, give it a name, and then that'll compile the block for use for broadcast. So if we pop in here, probably the better way to set up a smart stage would be to generate a three-sided 3D object using the dimensions of your LED. Since for this demo it's just an entirely theoretical smart stage, I'm just going to use the Disguise screens in order to generate that. So let's get rid of our projection surface and our projector, as we won't be needing those. Our puck can, we don't need a dimension, he can go out of the way. There we go. So three sides of LED. There we go. LED left. Let's just make, again, you would be using the resolution based on the pitch of the LED that you're using, and you'd use the product spec to do that. I'm just giving us a reasonable fictional resolution on this. Let's make this say 3 meters squared. It's probably a good one. And then because my anchor point's in the center of the screen, we're kind of half transecting the floor. So if I set this to half my height, so if that's 3, this needs to be 1.5, and that places it exactly on the floor. Again, you'd want to, use the real world measurements. Let's, I think it's that. No, we just want to angle this round a little bit. Let's make this, because it's to the left, -45. And then I'm going to copy this, because it's some of the parameter is going to be useful to us. We'll just make an LED right. And then we can make that positive 45. These are intersecting each other, so we just need to sort of move those out a bit. We could have moved the left as well and made that exactly sort of down the centre line, but I don't think that really matters. One more, we're going to make LED floor, and then because we made this from scratch, we have to set our resolution again. Let's just move our floor position down a little bit so that we're not intersecting the LED with our floor, and then just pull this into shape. So I can use control on the keyboard, and that increases the accuracy of the numbers that I'm putting in here. If I let control go, we're now stepping in 10 centimeter increments, which sort of, well, actually does work for us there, but we can just make that a little bit nicer. In fact, if you press shift, you can make that even further. So if I press shift on that, that'll be moving in complete meters, one at a time. So it's a case of hold shift to kind of get close, and then control to kind of dial those in carefully. Anyway, disguise tips and tricks. So this is the kind of thing that we would have on a smart stage. Our performer, if we bring our puck back, will be performing on the stage, and would be able to react to the sort of content that they can see around them, and then the AR can kind of happen further into distance around that. So it's quite a nice way of sort of improving on the sort of traditional green screen setup. We're going to want to bring our notch block in. We're also going to need a camera for this, so let's do that. So that by default it comes in right at the centre of the stage. A bit like last week, I'm going to use Andy Coates's Cinema 4D plugin to generate some Stipe data, because funnily enough, I don't have a Stipe system set up in my house, so this is quite a handy way of just being able to replicate a little bit of sort of motion control data. So just wait for Cinema 4D to load. When you generate a camera, so if I bring my notch block in and just look at that. Just guys, gonna load the block up. There we go. So when you generate a camera, it brings a perspective map into the scene, which is basically what the camera can see. So if we now look through our camera, we need to add our screens to that. So you can sort of see right now the camera's just kind of disappearing behind there, but so the content from the camera's perspective is now going to be projected onto our smart stage. Cinema 4D has now loaded, so I can grab Andy's plugin, which he calls Momentum. So I just need to pick that up, and now basically the camera movements that we define here are going to be output using the Stipe protocol. So I'm just going to flatten that out. See that circles. Oh, might not be too bad. It's kind of let's just zero out our camera targets. Oh, this is fairly zeroed. Oh, easy. There we go. So now the camera's going to rotate around. It's a little bit higher. Let's make that same height as me. So back in, this is just going to output this on port 6000. So I can essentially lose that now. I set up in my scene, I need a screen position. And then I need to set up a driver for Stipe. The main thing that we need to do in the driver is just set the port, which we know from the plugin that is 6000. I think the one that's set there by default is the one that the physical Stipe system would use. That needs to be set to engaged, and then if we find our AR camera, I can say tracking source Stipe, and now what that can see in the scene is being rendered onto our stage. I guess the question that I've got here is, why is that looking the wrong way? So we're going to pop back into our notch scene and just have a quick look. I think that is probably facing backwards that way. So obviously this would be a case of sorting out your incoming data if this was sort of kind of real world. But let's the way to do this here would be to grab a camera target and move it to the other side of us. Let's just have a quick look at that. It is doing that correctly. So, into the scene is plus Z, and that's minus Z. So we were right first time. See why. Just pause that so I can have a little look. So this is what it's saying. Just going to network edit this block from my notch builder so that we can modify some of the parameters live. Okay. That's probably why my exposable camera was set to the wasn't set to anything. So let's have a quick look at that. So basically now, as our slide camera moves, our background's going to update to always keep that the same as the field of view of our camera. Now we're a little bit too far off the back there, so I can use the network editing this to just push that further into the scene. Something like that. Oh, it's taking that, it's overriding that with our values there. Let's see if we can. That's modifying our sort of camera frame of reference. So we actually do need to do this inside the block. So we can grab our two nulls there. We should be able to pull those back. Just look at that. Better. Cool. Okay. I think we're drawn to a close of in terms of what's going on here. As you can see, it takes a little bit of fiddling. I think that the mesh overlay on top of my sort of the solid object isn't working quite the way I would like to see that working. I think it's worth mentioning that, you know, all of these things take a little bit of fiddling once you sort of get them to sort of make your real world and your virtual world align when you get on site. Oh, there we go. So I think we're going to call that the end of this. Oh, mind that. Let's make that stop. I think this one. Yeah, let's not make that. So I think that we're going to call that the end of that. Let's just see if we have any questions for today, and then. Is it possible to, Andrew Watts says, is it possible to get a link to the Stipe generator, please? It has not been officially released by Andy Coates yet, but he promises me it's going to be out very soon. I'm unfortunately not at liberty to sort of share that, but I will link his blog when this goes up on YouTube, and I imagine it'll be in the next couple of weeks. So yeah. That's been really useful to the kind of sort of AR testing I've been doing. If there are no more questions, I just want to say thank you for turning up today. Hope it was useful and you've learned something, and look forward to seeing you next week. So yeah, thank you very much.